One thing we have to understand really well for system design is the client server model. This is a super important concept for pretty much all system design and distributed systems. Think of it as the foundation of the internet and communication between systems. The best way to cover this is through an example. So we'll use going to youtube.com as our example. Let's start off really simple and define what we mean by the client and server. Essentially, a client is something that makes a request to a server, and a server is something that responds to a client request. We can think of the client as a browser in our example, and the server as YouTube's server. You can see here that the client, which can be the browser or a phone, sends data to our server, which can be either something like Google Cloud or a self-hosted server, and the server then responds with some data. Ultimately, the client probably doesn't know where or what the server is when you go to youtube.com. So how do we know where to go? How does the client know to send a request to the YouTube server that sits in a data center somewhere? You could think of it in terms of sending a letter or a parcel. You write an address on the parcel, you send it off to the delivery company, they look up the address and work out where the parcel needs to go, and then they deliver the parcel. This happens through something called the Domain Name System, or DNS. Every device connected to the internet has a unique IP address, which other machines can use to find it. The DNS server eliminates the need for humans to memorize IP addresses, as they're not very readable or memorable. Let's take a look at how a DNS lookup actually works. So when you type in to your client, to your browser, youtube.com and hit enter, what actually happens is what's known as a DNS lookup. The first step is you've typed in youtube.com into your web browser, and the query travels into the internet and is received by a DNS recursive resolver, which we can see here. Next up, the resolver then queries the DNS root name server. The root server then responds to the resolver with the address of the top level domain, or TLD, DNS server such as .com or .net, which stores information for its domains. When searching for youtube.com, our request is pointed to the .com TLD. The resolver then makes a request to the .com TLD, or top level domain. The TLD server then responds with the IP address of the domain's name server, youtube.com. Lastly, the recursive resolver sends the query to the domain's name server. The IP address for youtube.com is then returned to the resolver from the name server. The DNS resolver then responds to the web browser with the IP address of the domain requested. In our case, 74.125.142.91. At this point, our client now knows the IP address of youtube.com, and it can make a HTTP request to youtube.com. And you can see this here in the diagram. We make the HTTP request with the IP address. That'll be in the actual request. And the server then responds with some HTML in this particular case. If you're on a Unix operating system like Mac OS, you can make what's known as a DIG request, which is basically a DNS request to a website like youtube.com. And you'll see you get back basically a DNS record. And you can see here you've got the IP address. And that's how you can work out what IP address is there for a particular website. The final thing we need to cover are ports. So we know that a server is essentially sat there listening for client requests. And the way that servers know to handle certain requests is based on the port number. Now, certain network protocols that we'll cover in a later video all use a standardized port number. So for HTTP, it's port 80. For HTTPS, it's port 443. For SMTP, which is the email port, it's 25. And for a WHOIS request, it's port 43. Now, to come back to our parcel delivery analogy from earlier, you can think of ports as the apartment number in a skyscraper. So the IP address would be the building itself, and then the port number would be the individual apartment. Without the port number, we don't actually know which apartment we are sending the parcel to, and it's the same with any kind of client server request. We need to know which ports we actually want to go to. Okay, there's one final little exercise we can do to simulate the client server model using the NC command, which I think stands for netcat. So in our server here on the left-hand side, you're going to do nc-l, which means listen, and then you're going to pass in a port number. So let's do 8080. And on the left-hand side, we now have our server. On the right-hand side, we're now going to create our client. So we're going to do, again, netcat again. And then we're going to use our local host IP address here. So 127.0.0.1. And you've probably seen that all over the place. Now, same port again, so port 8080. We now have our client on the right and our server on the left. So if we go ahead and type something into our client, like hi, we'll see that it's reflected on the server on the left-hand side. And on the server, we can go hello, and it will appear on the client on the right. Obviously, my typing is very terrible there, but you get the idea. So you can simulate the client server model using NC or netcat in your local terminal and just play around with that. And that's it. In this video, we've covered the client server model, so hopefully you understand that a bit better. We've also looked at how a DNS request works. So up next, we're going to cover network protocols and understand a bit more about how these requests actually happen, how the data is transferred. So thanks for watching, and I'll catch you in the next video.